Bismillahirrahmanirrahim. This work, titled Electrical Property Enhancement of Nanocomposite based on polyaniline aldehyde grafted nanocellulose, prepared by Ryad, Lemkeddem, Ouargla, and Ryad. As it is known, flexible and electroconductive composites have attracted extensive attention because of their potential future application. That's why we have concentrated in such subject. At the first, I see that important to give a quick overview of this work, which devoted to prepare two composites based on treated and untreated nanocellulose extracted from that palm residues and coated with polyaniline to obtain conductive composites, and lastly characterized by several techniques. It found that 23 ANC pani composite behave as SDN, super dielectric material. The benefits gained of this work are the following outcomes: preparing materials with high dielectric constant for electrical energy storage. The second, environmental management using the dead palm residues that have about 238,000 tons per year, opening a window on theoretical research, effect of vacuumization on the gap energy of pani composite. In order to get MNC and 23 ANC pani composites, there are several steps should be followed. Some of them present in the picture below. At first, that palm fibers preparation, that means physical treatment. The second step is extraction of cellulose. The third step, transforming cellulose fiber to micro nanocellulose MNC by hydrolysis, and then selective and controlled functionalization of micro nanocellulose. Last step, in situ oxidative polymerization of aniline on the surface of MNC. As it's shown, there are many techniques are used to characterize the products obtained during steps of preparation, like FTIR, scanning electron microscopy, and EDAS, energy dispersive spectroscopy. In this work, we have studied the DC conductivity of prepared composites as function of temperature. As it's shown in the graph, the dry conductive nanocomposite 23 ANC pani has a DC conductivity of 5.2 siemens by centimeter at 20 degrees Celsius. Its conductivity became 4 times higher than the one based on the non-functionalized nanocellulose. To study dielectric property of obtained composites, it's important to present the following equation. Dielectric constant, or relative permittivity, epsilon R equal epsilon by epsilon 0. Epsilon complex frequency dependent absolute permittivity of material. Epsilon 0 is electric constant or permittivity of free space. Epsilon in general equal epsilon R by epsilon 0. The capacity of a sample parallel plate capacitor or supercapacitor is given by C equal epsilon by A over D. A is the area of the parallel plate. D is the separation between the two plates. C equal epsilon F by epsilon 0 by A, the area, over the distance between two plates. The real part of the permittivity related to the storage energy in the material, and the imaginary part of the permittivity related to the loss of energy in the material, loss factor. The dielectric loss can also be expressed as tangent of phase shift angle, tangent gamma equal the imaginary part over the real part of the permittivity. To show the effect of functionalization of nanocellulose on the conductivity, it's important to measure the carbonyl content. In the case of MnC, the carbonyl content by millimole by gram equals to 0.004, while in the case of 23ANC, we have found that the carbonyl content equals to 0.149. Results obtained. Dielectric constant of MnC funny composites equals 83.41 at 10 to the power of -2 Hertz, of course, while the dielectric constant of 23 ANC funny equals 2.661 by 10 to the power of 10 at 20 degrees Celsius, and equals 2.742 by 10 to the power of 10 at 25 degrees Celsius, of course at 10 to the power of -2 Hertz. It found that 23 ANC funny composite behave as SDM, super dielectric material. Its electrical property near the dielectric constant of silicon dioxide and greater than the one of aluminum. The results obtained clearly show that 23 ANC funny composite is a super dielectric material. For this reason, it's advisable to use it in super capacitor. Thank you very much for your attention.